Hi students, in this video I'll be going through the JYSS Sec 4E 2022 mid-year exam paper for A Math. So this one is the paper 2 question 5. Alright, so this is a question regarding the equations of tangents and normals. So let's read the question. So the question goes, the equation of a curve is y equals to ax to the power of 4 plus bx, where a and b are constants. So the equation of the normal to the curve at the point x equals to 1 is 2y equals to x plus 7. Find the value of a and b. Okay, so this is a typical type of question whereby there are two unknowns. So whenever we want to solve for two unknowns, we will need two equations. Then we will try to solve those two equations simultaneously to get the values of a and b. Right, but before we start solving the question, just let us draw a rough sketch of this particular scenario and then help us to visualize the question better. Okay, I don't know how the curve is going to look like, so I'm just going to draw a random curve. Right, so we're going to draw a random curve like this. Okay, so let's say this one is the point where x equals to 1 now. Okay, so x equals to 1. Okay, I don't know the y coordinate. Okay, so what is the info that is given to us here? Okay, so the info that is given to us here is that the equation to the normal of the curve at this particular point is 2y equals to x plus 7. Okay, so if you make y the subject, you will get y equals to half x plus 7 over 2. Okay, which means there is a positive gradient now. Okay, so the tangent the normal will look something like this. Okay, so the normal to the curve will look something like this. Okay, so this one will be the normal. Okay. Okay, the equation is 2y equals to x plus 7. Okay, so this is the info that is given to us. Okay, so remember we want to form two equations, right? So usually one of the equation will come from substituting this pair of coordinates into the equation of the curve, because the curve passes through this point 1 something, okay, which we don't know the y value yet. Okay, but since we know that this normal also passes through this point, what we can do is we can sub x equals to 1 inside here, and then we find the y, and that will give us the y coordinate here. Okay, then once we know the pair of points, we can sub the pair of points inside the equation of the curve to get our first equation, right? So that is basically what we are going to do. Okay, so let's write down the solution. So when x equals to 1, okay, we sub x equals to 1 inside the equation of this normal, because the normal passes through this point, okay, over here, which the curve also passes through, right? So 2y will be equals to x. Okay, so replace x with 1 plus 7, so 8, so y will be equals to 4. So now we know the coordinate of this point is 1, 4 already, right? So what we can write is the curve and normal, okay, passes through 1, 4. Okay, so since the curve passes through 1, 4, we can use this 1, 4 to get our first equation. So when x equals to 1, y will be equals to 4. Okay, so let's sub in, okay, y4 and then x1, okay. So a 1 to the power of 4 plus b1 equals to y4, right? So we'll get a plus b equals to 4. Okay, so this is equation 1. Okay, so remember for this kind of question is usually typical. It may not always 100% always be this case, but to sub in a pair of coordinates whereby the curve passes through to get one of your equations. Okay. Okay, so now we need a second equation, right, in order to solve simultaneously. So where is this second equation going to come from? Okay, it's definitely, for this kind of question, it's definitely going to come from the dy dx. Okay, basically, if we do dy dx for this y, we are going to get the gradient function. Okay, but the gradient function will give you the gradient of the tangent. Okay, gradient of tangent. Okay, remember dy dx always gives you the gradient of tangent and not the gradient of the normal. Okay, so when we do dy dx, then we sub x equals to 1 inside. That will give us the gradient of the tangent. Okay, so let's look back at this diagram. Are we able to find what is the gradient of the tangent? Okay, to find the gradient of tangent, we need to ask ourselves one question. We are given a normal, right? Do we know the gradient of the normal now? So the answer is actually yes, right? We can actually find the gradient of normal quite easily by making y the subject. Okay, putting this equation of this line in the form y equal to mx plus c. Then the m will be the gradient of the normal, right? Okay, so that's what we're going to do. Okay, so the normal is this, so the normal, okay, so maybe write equation of normal is 2y equals to x plus 7. So we're going to make y the subject. So y will be equal to half x plus 7 over 2. Okay, so this half over here, this half over here will be the gradient of the normal. So gradient of normal will be equals to half. Okay, let me write this properly. Gradient of normal. Okay, so I write gradient of normal equals to half. Okay, so the tangent is perpendicular to the normal. Okay, let me change the color of the thing. Okay, where will be the tangent? The tangent will be over here. Okay, like that. Yes. Okay, so the tangent is perpendicular to the normal always. Okay, so from here we will be able to find the gradient of the tangent, because since they are perpendicular, the product of the gradient of the tangent times the gradient of the normal will give us -1. So gradient of tangent times half will give us -1. So gradient of tangent will be -2. Okay, so this gradient here will be -2. Okay, so gradient of tangent equals to -2. So in other words, what we can say is that dy dx will be -2 when x is equals to 1, because this tangent touches the point whereby x coordinate is 1. Okay, so now what we need to do is we need to find dy dx first. So the equation is y equals to ax to the power of 4 plus bx, right? So y equals to ax to the power of 4 plus bx. So let's find dy dx. So 4ax cubed plus b, right? Okay, so now we're going to sub in. So when x equals to 1, okay, so remember we're going to sub in this pair of condition, dy dx equals to 2, okay, to get equation 2, okay, dy dx equals to, dy dx equals to -2, right? So let's do that. So substitute the x with 1, so 1 cubed plus b equals to -2. So you'll get 4a plus b equals to -2. So this will be equation 2. Okay, then remember equation 1 is just on top over here, a plus b equals to 4, right? Okay, maybe I write equation 1 again over here, a plus b equals to 4. This is equation 1. Okay, so since b both have b, what we can do is equation 2 minus equation 1. 2 minus 1, so left side of the equation minus the left side. So remember, put a bracket, you're minusing this whole thing, right? Will be equals to -2 right side minus right side. Okay, so here we'll just end up with 3a equals to -6. So a will be -2. Okay, then we'll just sub a equals to -2. A equals to -2 into equation 1. So we will get -2 plus b equals to 4. So b will be equals to 6. Okay, so a -2, b equals to 6, okay, which is the answer over here. Okay, so questions like this. Okay, so just remember, you can go and do your flare or tenor series, and you will see questions that are similar to this. Whenever you see two unknowns, you think about forming two equations. So usually one equation will come from substituting the coordinates of the point whereby the curve passes through to get equation 1. Then equation 2 usually formed by equating the dy dx, okay, at that particular point to a certain value, which should be given in the question. Okay, then you will get your two equations, and then you can solve it and find the two unknowns, right?